All right, my channel, the application of differential equation, and in particular, I will be talking about the application of first order differential equation. And then the first one we're going to be talking about in this video is about population growth and decay. So we'll be talking about decay and growth of population. Okay, so we say growth and decay. Okay, growth and decay problems. Now, for this growth and decay problem, let us assume that n of t is the present population of a, do I call it a disease or an organism or anything at all. Okay, in fact, let n of t be the current population. So if n of t be the current population, in population growth, if it is population growth, we say that the change in population with time is directly proportional to the current population. Okay, I'm going to derive it. Then after deriving it, we will now use what we derive to solve so many problems. So if the change in population is directly proportional to the current population, to remove proportionality sign, we are going to have that the n, the t, don't forget that n is a function of t, is equal to what? K, or we can use r, let's use r n of t, where r is what? The what? Proportionality constant. Don't forget that in mathematics, if you remove proportionality, you bring in proportionality constant. Now, this is separable. We can use separable, or we can use what is it called? Linear equation. So let us use separable here. Then I'm going to be using linear equation here so that you see that they are the same thing. So using separable, we have that the n over n will come down to be what? To be n is equal to what? R dt. Okay, don't forget that all the n here are functions of t. So now, if we integrate both sides, we are going to be having that. If we integrate both sides, we are going to be having that the integral of 1 over n, the n, is equal to what? The integral of r dt. So now, the integration of 1 over n is what? Is ln n, is equal to the integration of r will give you rt plus a constant. So if we take the exponential of both sides, we are going to be having that exponential ln n is equal to exponential rt plus a constant. So exponential is the opposite of ln. So I now have that n will now give you exponential rt multiplied by exponential c. And the exponential of a constant is still a constant. So I'm going to have that the n of t, the current population, is equal to what? Let's take exponential c to be n of 0. Okay, n of 0, or some can say n naught. You can just call it n naught exponential rt. Now, this is the formula to calculate the current population of any organism or anything at all. This is formula to calculate when it is growing. If it is growing, remember that the first one I derived is for growth. Okay, this is for growth. So even if you want to use linear equation to solve this side, alternatively, if you want to use linear equation, we are going to be having that the n over the t here, the n over the t, this one coming here will give us minus rn is equal to 0. So this is linear equation where our p of t is equal to the coefficient of this, which is what? Minus r. And then our q of t is going to be what? Be 0. So to get our integrating factor, we are going to have exponential integral of p of t dt. So which is something as saying exponential of the integral of minus r dt. So which will give you that this is the integrating factor will now be equal to what? So the integrating factor will now be equal to what? Exponential minus rt. Okay, so don't forget that our solution becomes that what? N multiplied by integrating factor is equal to the integral of q of t multiplied by integrating factor dt. So any method you like will give you the same solution. So n multiplied by exponential minus RT will now be equal to what? What do we have here? This is integral of 0 multiplied by exponential minus RT dt. So integration of 0 will give you just a constant. Okay. So since it's giving us just a constant, so we now have that n here, exponential minus RT is giving us any constant. Let me call it n of 0. Okay. So if this now move to this side, you will now see that the current population is going to give us, this is negative. So moving here becomes positive. So I have n naught exponential RT. Okay. So any method you like will give you the same result for the derivation. So now, let us now talk about when it is decaying. The difference between the growth and the decay is, here is going to be minus. That's not the difference. The power of the rate is going to be minus. So we are going to have that. So for decay, you will now know that the n dt is equal to what? Minus n of t. You know why it is negative? Because it is decaying. It's not growing. So since it's growing, we have negative. So from here, we do the same thing again. You can decide to, directly proportional, not equal to, please. Directly proportional. Let me refill. So directly proportional. So that means that if we remove our proportionality sign, we're going to have that the n dt will now be equal to what? Minus Rn. Okay? So if we do separable again, the over n dt. So if we integrate both sides, I'm going to have the integral of 1 over n dn is equal to the integral of minus r dt. So you have that what? Ln n is equal to what? Exponential minus rt plus c. So we are going to have that here. Sorry, this is minus rt plus c. So if we take exponential of both sides, we now have that n will give you exponential minus rt plus a constant. So which is what? N will now be exponential minus rt multiplied by exponential c. So n becomes n naught exponential minus rt. So the difference between decay and growth is what? Negative in the power here. So let us now solve some calculation to illustrate what we have done so far. Okay? Because without calculation, I don't think you understand what I'm trying to say. But at least you have learned how to derive it in case you are asked to derive it in exam hall. You have learned it. So let us solve some problem. The first problem we are going to be solving here say that a person places 20,000 in a savings account with pays 5% interest per annum, compounded continuously. Then they now say find a question, the amount in the account, after 3 years. B, they say the time required for the account to double in value. Then I say presuming no withdrawal. Okay, no withdrawals and no additional deposit. Okay. Now, we want to, in this type of question, we're talking about growth in population. Okay. How we are talking about the growth of this particular money. So remember that formula for our growth from what we derived is that the n over the t is equal to what? Sorry. We derived that we derived that that n, the current one, is going to give us the present one exponential RT. Okay, where R is now the rate. The R in this case is what? Is the rate. So we are going to have that. So let's do that. So let us put it now. So N naught is the initial amount, and the initial amount in the account is $20. $20,000 is the initial one. So the rate is 5%. That is 5 over 100, which is what? 0.05 is the rate. Okay. So now, if we now put it here, so they are asking us in the next 3 years. So the time for question number A, the time here is now 3. So you now have that the current amount will give us what? 20,000 exponential, 20,000 exponential 3 times that, 3 times 0.05. So we are going to be having, I'm not even with my calculator here. So do that and then tell me what you think the answer is at the comment section. Okay? So we are going to be having that the money in their account will now be. So do this. Just do this and tell me what the answer is at the comment section, because I forgot my calculator. So I'm not with my calculator here. So this will not be the amount. Just press 3 times this. You now press exponential this. Then 2,000 times that answer will now give you the final answer. Okay? So that is that. So question number II is not asking us to calculate the time. So we have that our n for question number B, n is equal to what? N naught exponential RT. Okay? Now, if we are going back, we are going to have that. If you are going back, we are going to what? To take the ln of both sides. So we're going to take the ln of both sides. But before that, don't forget that we are looking for what? We are looking for our t. And they're asking us what time will it double? Okay? What time will this amount double? So this amount doubling will be the current one. The current one is the double of this. So double of 20,000 will give you 40,000. So we have 40,000 here. 40,000 is equal to, so the initial one is 20,000. So 20,000, then exponential. The rate, we know the rate now. The rate is 0.05. So 0.05t. Okay? Even if you don't want to do it this way, sir, you can now say that double of the initial. If you don't want to do it this way, you will now say double of n naught equal to what? The n naught exponential RT. And R is your what? 0.05t. So n naught cancelling n naught, we are having 2 here. So the same thing is applicable here. So if 2,000 cancels this, I'm going to have 2 here, because 0 take care of 0, 0 take care of 0, 0 take care of 0, 0 take care of 0. I'm left with 2 divide itself, 1, 2 divide here, 2. So I'm left with 2 is equal to exponential 0.05t. So taking the ln of both sides, we are going to have that ln 2 is equal to what? Ln the exponential of 0.05t. So ln is opposite of exponential. They cancel out itself. So we have ln 2 is equal to 0.05t. So the t I'm looking for will now be what? Ln 2 divided by 0.05. So that is the time. So press it in your calculator and tell me what you think the answer will be in the comment section. So how many years did you get? In how many years will it double? So that is the first question. So we go to the second question. If time permits up, we are going to solve about 5 questions for this population. So after population, we look at another application of first order differential equation, where we will talk about temperature. We'll look at temperature. How do we apply first order differential equation to temperature? So now, the second question here said that a person. Okay, I'm not going to be solving for. Okay, let this one be your assignment. Let this one be your assignment. That a person placed 5,000 naira in an account that 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 occurs interest compounded continuously. So assuming no additional deposit or withdrawal, how much will be in the account after seven years? Okay, after 7 years, if the interest rate is a constant 8.5% for the first 4 years and a constant 9.25% for the last 3 years. Okay, so it's a very simple this thing. What you do is you calculate calculate the first 3 years and then calculate the first 4 years and then you add the both of them together. That is very easy to do. So that should be your assignment. So let's talk about the example 2. Example 2 here said what constant interest. Why are they talking about only interest here? We're not talking about bacteria. Okay. What constant interest is required if an initial deposit placed into an account that occurs interest compounded continuously is to double its value in 6 years. Okay, now this one, they're not asking us the interest rate. If they're asking us the interest rate, we use the same formula again. Solution, we're having that n, the current population is equal to the initial population exponential RT. Don't forget. So they are looking for the rate that will make it to double after how many years? After 6 years. So we're going to have that 2 of n naught. Okay, 2 of this is the current one. Is equal to what? N naught exponential 6 times r. Okay, so if n naught cancel n naught, I'm having that exponential 6r is equal to 2. So taking the lane of both sides, I'm going to have that 6r will now be equal to lane 2. So our r will now be what? Lane 2 divided by 6. That is our r. And don't forget that this is in percentage. So anything you get here, you still divide it by 100 so that it will be in percent. Is it not? Or sorry, you multiply by 100. Please, you multiply by 100. Anything you get here, you multiply it by 100. Okay, so that it will be in percent. Yes. So anything I'm getting here, the rate is here times 100. So that is your rate. So tell me what the answer is in the comment section, because I told you initially that I did not come with my calculator. So we'll solve at least 5 questions here. Let us be sure that we have understood it very, very well. So let's talk about bacteria. Bacteria in